Late afternoon settles in and very slowly. The last light of the day rests quietly upon the rooftops, and the air itself seems to soften, as though the whole world is drawing in a deep breath before night arrives. Somewhere, a very gentle breeze passes by the window, carrying the scent of earth, the scent of water, and movements too subtle for ordinary eyes to see. In that quiet moment, the sky appears calm. Yet above us, the air continues to drift, warmth continues to rise, and invisible droplets are changing form among distant layers of cloud. Weather is not only rain or sunlight, it is a slow story of energy, of balance, continually finding its way back to itself. Let this video be a small pause, a place to listen to science told at an unhurried pace, gentle enough to relax, deep enough to invite reflection. As we step together into the way the sky truly moves. What is the atmosphere? Foundation. If one stands beneath the sky for a long while on a quiet evening, the air may seem to have no shape at all. It has no color, no distinct scent, and leaves no trace in the hand when we reach forward. Yet, it is precisely this invisibility that makes it strange. For even though we cannot see it, we live within it, like a small creature immersed in the ocean, unaware that water is holding it gently from every side. Earth's atmosphere is not a rigid dome or a sealed shell. It is more like a soft blanket, so thin that if this planet were reduced to a small sphere resting on a study desk, the layer of air where clouds drift and winds move would resemble only a very light coat of paint upon its surface. And yet, that fragile layer keeps warmth from escaping, carries water across continents, and softens the harshness of the cold emptiness beyond. Air is composed mostly of nitrogen, a nearly silent gas, slow to react, like a quiet background tone beneath a long piece of music. Mixed within it is oxygen, which every breath we take temporarily borrows to sustain life. A very small remainder consists of less noticed guests, argon, carbon dioxide, and countless other traces. They are present in such small amounts that they may seem insignificant. Yet sometimes it is precisely these small things that change how light travels through the sky, how heat is held, or how it departs. Among all these components, water vapor is the one that is always changing. In some places it is almost absent, like the distant cold air of the far polar regions. In others, it gathers densely, carrying the heavy, humid feeling of tropical afternoons. It arrives and leaves, rises, condenses, disappears, and returns again, carrying energy that ordinary eyes cannot perceive. Air may seem light, yet it has weight. Each of us lives beneath the pressure of a column of air, stretching tens or even hundreds of kilometers above our heads. That pressure does not feel heavy because the body has known it since birth. Like a gentle hand resting on the shoulder for so long that we forget it is there. Gravity draws gas molecules downward toward the surface, while the pressure created by that very weight supports the air above. Two opposing forces quietly balance one another. The air does not collapse downward, nor does it drift away into space. It floats in a delicate equilibrium, like the surface of water in a bowl kept perfectly still when no one touches it. The higher one goes, the thinner the air becomes. Not because there is a sharp boundary, but because the molecules gradually move farther apart. At the summits of very high mountains, each breath grows shorter, as though the sky itself were retreating from human reach. The air remains present, yet the spaces between molecules grow larger and pressure decreases. Scientists often divide the sky into layers to make it easier to understand. But if sensed intuitively, They can be imagined as different regions within the same ocean. Near the ground lies the most lively place, where birds fly, clouds gather, rain falls upon rooftops, where warmth from the surface rises upward, and even the smallest movements may become wind. This is the troposphere, the layer where nearly all weather occurs, a region not especially tall compared with the size of the planet, yet one that contains almost every familiar change of human life. There, temperature generally decreases with height, that cooling creates motion. Warm air near the ground becomes lighter and wishes to rise. Cooler air above becomes heavier and wishes to descend. And between those opposing inclinations, the sky begins to breathe. Without changes in temperature with altitude, clouds might form less often, and winds might rarely travel far. But because Earth receives sunlight unevenly, because land and water absorb heat differently, differences are always present. The air responds to those differences by moving. The relationship between temperature, pressure, and air density can be written as neat mathematical equations. Yet without the symbols of mathematics, it may be understood more simply. When air warms, its molecules move faster. They drift slightly farther apart, allowing the air mass to expand and become lighter. When cooled, they slow down, draw closer together, and become denser and heavier. That small difference is enough to create immense motion. A warm region of air may slightly lower surface pressure. A colder region may increase it. Air begins to slide from areas of higher pressure toward lower ones, like water finding its way downhill. That is what we call wind, even when it is only a faint breath passing quietly through a doorway. Differences in pressure are often very small compared with the total weight of the sky. Yet those small imbalances ensure that the air is never completely still. Like a vast lake whose surface always carries small ripples, even when no stone has been thrown into it. Above the troposphere, temperature begins to change in another way. Some layers of air become more stable, less disturbed. Aircraft often fly near that boundary where motion softens. Yet most of the story of rain, of wind, and of the clouds we see each day still unfolds much lower, within the air closest to human life. If one stands outdoors in the early morning, when moisture still rests upon the leaves and new light has only just touched the ground, the presence of this layer of air can be felt clearly. It holds the warmth of yesterday, carries humidity from distant rivers, and sometimes even dust from lands we have never visited. All of this exists through a fragile balance. Gravity pulls downward, heat pushes upward, pressure spreads sideways. The air expands and contracts, continually adapting to the energy moving through it. There is no moment when the sky is completely motionless, even when it seems to be asleep. And within this seemingly ordinary layer of air, every future rainstorm is quietly preparing itself. Distant winds begin with only a small change in temperature. Clouds form from the meeting of countless molecules no one can see. Understanding this does not take away the sky's sense of peace. Instead, it deepens it. For behind the gentleness of a windless evening lies an entire system balancing itself each second, very slowly, very patiently. And when we look upward, perhaps the most remarkable thing is not whatever turbulence may be unfolding somewhere far away, but the way this fragile layer of air remains here, supporting every breath, holding warmth close, and quietly preparing the next chapter of the sky, already beginning to move. The origin of everything. The sun. And while that fragile layer of air continues to balance itself in silence, something else is still unfolding far away, farther than every cloud, and farther even than the edge of the blue sky familiar to our eyes. Not above in the sense of distance, but at the source of all motion, a place where light is born from collisions no one can hear, within a space so hot that imagination itself can scarcely reach it. The sun does not burn like a flame on earth. There is no smoke, no explosions, no sparks scattering into darkness. Deep within its core, particles smaller than anything we have ever seen move close to one another, close enough to merge into something new. When they do, a very small part of themselves disappears, and that disappearance becomes energy. Not energy in a hurried or violent human sense, but a steady, luminous flow, quiet and enduring, sustained across billions of years. Those rays of light do not leave at once. They wander within the sun for a very long time, colliding, changing direction, held back and then continuing again. Some particles of light require thousands of years to find their way out through that radiant surface. Yet once released, they cross the nearly empty expanse of space in only a few brief minutes, moving silently toward Earth. 8 minutes after departing, a very small portion of that light reaches the atmosphere. No one hears that moment. There is no sound to announce it. But from that instant, the story of weather begins. Light does not fall upon this planet evenly. Earth is a sphere turning slowly through space, and each place receives sunlight at a different angle. Near the equator, light arrives almost directly overhead, concentrated and warm. In regions closer to the poles, it leans sideways, spreading across a wider area, like a lamp placed farther and farther from a tabletop. That difference is so subtle that we rarely consider it when stepping outside in the morning. Yet the air feels it clearly. Land and water absorb heat in their own ways. The oceans drink in sunlight slowly, holding warmth like a long memory. Deserts reflect more, returning to the sky a portion of what they receive. Dark forests absorb sunlight more deeply than pale sand. Snow and ice, meanwhile, send much of the light back toward space, like cold mirrors. Each surface makes a different response to the same source of light. And from those responses, temperature begins to diverge, little by little. Some places retain more energy. Others allow it to leave more quickly. These differences are not loud. They resemble small changes in the heartbeat of the planet. Yet the air above cannot ignore them. Warmer regions grow lighter. Colder regions grow heavier, and motion begins, like the natural breath of a body seeking balance. Seen from afar, Earth also tilts gently along its orbit, a tilt just sufficient to create the seasons. Not because the distance to the sun changes greatly, but because the angle at which light touches each hemisphere changes with time. For certain months, sunlight lingers longer in the north. In others, it softens over the south. Days lengthen and then shorten again. The shadows of trees change direction. The air remembers these changes in its own way. Oceans warm slowly throughout summer, then release that warmth when winter arrives. Land responds more quickly, heating beneath sunlight and cooling when nights grow longer. This unevenness prevents energy from remaining still. Near the equator, the planet receives more light than it can radiate back into space. In polar regions, the opposite occurs. More heat is lost than received. Between those two places lies a vast imbalance, like the ends of a melody resting at different notes. Air and ocean become quiet carriers. They transport warmth away from the tropics, guiding it toward colder regions. Not from intention, but because physics always seeks equilibrium. Every wind begins with that difference. Every cloud as well. Even the gentle breeze passing a window in the evening may carry traces of sunlight that touched the ocean days before. It is easy to forget that the light we feel upon our skin during the day began its journey long before we awoke. It was born within the core of a star, crossed cold and dark space, passed through a thin atmosphere, and became warmth upon the ground, became the evaporation of water, became the motion of air. Weather does not begin with clouds or wind. It begins with a photon, a small particle of light carrying energy from afar. And when night arrives, when the sky darkens and stars appear, the planet continues its work. Heat received during the day begins to leave as infrared radiation, quietly returning to space. It is an exhale after breathing in light. Between those two breaths, receiving and releasing, the atmosphere continually adjusts itself. It carries energy, disperses it, gathers it again, and lets it go. There is no moment that is completely still. Yet this motion rarely troubles us. It resembles the flow of time itself, continuing whether we notice it or not. If one stands outdoors at sunset, when the final light leaves the rooftops and the remaining warmth upon the ground slowly dissolves into the air, this exchange can be felt clearly. A slow conversation between planet and universe. Unhurried, unstrained, light arrives. And then it leaves. And somewhere between those two journeys, weather is born, very gently, as though the sky is continuing its story through movements we only begin to notice when we truly pause to listen. How does air move? And then, after light has arrived, after warmth has been held by the oceans, by stone roads, and by fields resting beneath the shadow of evening, the air begins to respond in its own way, not through sound and not through sudden motion. Everything unfolds so slowly that, without attention, we might believe nothing has changed at all. Yet within that quietness, wind is born. If we place a hand close to the ground on a sunny afternoon, we can feel warmth rising upward. Sunlight touched the surface hours before, and the land answers by passing that energy into the air, resting beside it. Gas molecules receiving heat begin to move a little faster. No one can see that change, yet it resembles the way a room gradually warming begins to feel more open, easier to breathe within. Warm air expands gently. It does not disappear. It simply stretches outward, like a long breath. As it expands, it becomes lighter than the surrounding air that remains cooler. And because it is lighter, it begins to rise. No sound announces that moment. It is only a slow lifting, like a small bubble leaving the bottom of water. That rising motion is one of nature's simplest movements. A hot air balloon ascends for the same reason. Lighter air always finds its way upward. In the sky, this happens millions of times each day. Above rooftops absorbing sunlight, across dark asphalt roads, over stretches of sand where light lingers longer. When warm air leaves the ground, the small space it leaves behind cannot remain empty for long. Cooler air from elsewhere drifts in to replace it. That sideways movement is what we feel as a breeze, not because the air wishes to move, but because it is seeking balance again. Somewhere, pressure is slightly lower. Somewhere else, slightly higher. The difference is so small that if we held a leaf in our hand, we might not notice it at all. Yet for the sky, even a very small change is enough to begin motion stretching across hundreds of kilometers. Air slides from areas of higher pressure toward areas of lower pressure like water finding its way downhill. It is not a decision. It is a natural response to imbalance. And when that response unfolds across the planet at once, winds large and small begin to connect into continuous flows. Long ago, there was a time when people did not understand that air had weight. The sky seemed only an empty blue space, until a man in Italy in the 17th century turned a glass tube filled with mercury upside down into a bowl. He expected the liquid to drain away completely, but it did not fall entirely. Part of it remained suspended inside the tube, as though held in place by an invisible hand. Evangelista Torricelli realized that air itself was pressing down upon the surface of the liquid, supporting the column of mercury. The sky, it turned out, was not empty. It carried weight, and that weight changed with the weather. From that moment, people began to measure the breadth of the atmosphere. When pressure slowly fell, rain often approached. When it rose, the sky tended toward calm. Small changes inside an instrument resting upon a desk reflected immense movements unfolding overhead. Yet the journey of air does not end when it rises. As a mass of warm air ascends, the surrounding pressure gradually decreases. No longer compressed as tightly as it was near the ground, it expands further. And to expand, it must draw upon its own internal energy. Like a deep exhale on a cold night, the breath becomes cooler. Air therefore cools as it rises, even without exchanging heat with its surroundings. This cooling happens quietly, almost unnoticed. Yet it is an important moment. As temperature falls, the water vapor within approaches condensation. The first clouds may appear from this very silent process. Below, where cooler air sinks downward, a complete cycle of motion forms. Warm air rises, cold air descends. Between those two directions lies a slow circulation, like water gently simmering in a pot upon a stove, except that this vessel is as wide as the planet itself. Everything begins with heat. Heat creates difference. Difference creates pressure, and pressure opens the path for motion. Summer afternoons sometimes reveal this clearly. Air above a heated road shimmers like a transparent wave. There, warmth is lifting air upward. Over the nearby grass, where it is cooler, the air feels calmer. These small movements combine, becoming larger circulations that we only notice when leaves begin to rustle. Air does not rush. It does not plunge forward like water in a waterfall. It accelerates and slows, curls gently, and then dissolves again. Equations may describe this through complex symbols, yet the feeling of it is familiar. It is the soft breeze that moves a curtain, the coolness slipping through a collar as evening arrives. And sometimes, standing outdoors late at night, we may realize that wind does not come from any single place. It is the result of countless small changes happening at once. A beach that warmed since morning, a forest cooling after sunset, a distant air mass only just beginning to rise. All of these connect together, forming a motion we experience only as a very light touch upon the skin. Wind, in this way, is not a mystery. It is balance adjusting itself, a slow response of the sky to light that arrived from far away. And when we close our eyes, listening to leaves moving beyond the window, perhaps what matters most is not the direction the wind is traveling, but its patience. It never truly stops. It simply continues searching for a quieter state, little by little, as though the entire sky has been learning how to breathe deeply across billions of years. The global circulation. And as the wind continues its patient journey, passing over rooftops and across fields slowly dimming in the evening light, It is easy to believe that it belongs only to the place where we stand. A small movement in a garden, a cool breath slipping through a half-open window. Yet air rarely belongs to any single place. It comes from farther away than we imagine, carrying a story that began long before it touched anyone's skin. If we could observe this planet from the quiet distance of space, we would see that the atmosphere does not move through scattered motions alone. It flows in vast loops, very vast, slow like deep currents beneath the ocean's surface. Sunlight continues to warm regions near the equator more than elsewhere. There, land and sea absorb energy strongly, making the air lighter and causing it to rise again and again. That warm air cannot continue rising forever. Once high above, it begins to spread outward in both directions, searching for a path away from the heat. From afar, the movement resembles a breath expanding within the chest of the planet. It drifts northward and southward, carrying the warmth entrusted to it by light. Along that journey, the air gradually cools. Reaching the middle latitudes, it begins to sink. The descent is not loud. It is like a vast curtain lowering slowly. Places where air descends often become drier, their skies clearer. Many of the world's great deserts lie near these regions, as though the sky there holds its breath a little longer. After nearing the surface, the air turns back toward the equator once more. But the planet does not stand still. Earth turns continuously beneath that movement, bending the path away from a straight line. The air is drawn gently, yet persistently to one side, like water curving as it flows inside a slowly spinning bowl. From this arise the familiar winds of the oceans. They blow with such steadiness that ancient sailing ships once learned to trust them. Across wide seas, sails filled with wind without ever seeing the origin of that motion. Mariners gave them many names, yet in essence they were the returning breath of air after a long journey through the upper sky. Near the equator, where winds from both hemispheres meet, the air is forced upward once again. At the surface, winds there may sometimes feel weak, almost still. But above, columns of air rise strongly, carrying moisture from the oceans. Clouds gather. Rain falls more often. Deep green rainforests exist because of this quiet convergence, where the sky frequently opens into long rains. Farther toward the poles, another kind of motion begins to appear. Air from the subtropics moves toward colder regions. There, it encounters cold air masses drifting downward from the north or south. These different flows do not meet through violent collision, but through gentle spiraling. The familiar storms of temperate regions are born from such encounters. Winds at those latitudes often travel in different directions. They carry clouds and rain from the oceans onto land, cross continents, and then return again toward the sea. Cloudy mornings in Europe or passing rains across North America often begin far away, guided by those steady currents of air. Near the poles, where sunlight weakens and cold lingers, heavy air sinks close to the surface. It slides slowly toward the equator, cold and dry. Winds there are not always strong, but they are persistent. Another circulation closes upon itself, like large gears turning inside a machine without sound. All of these circulating patterns exist together, arranged beside one another, continuing in sequence, like ripples spreading across a lake when many stones are dropped at different places. No one commands them. Uneven sunlight and the slow turning of the planet are enough. Yet the story does not end at the surface. High above, where the air grows thinner and colder, there exist winds so fast that if visible, they might appear as rivers flowing through the sky. They are not as wide as oceans, yet they stretch for thousands of kilometers. Their speed surpasses any wind we feel near the ground. These currents form where warm and cold air meet at great altitude. Pressure tilts and air accelerates in search of balance. The turning planet bends them into long, sweeping curves, like soft brushstrokes drawn across the sky. From the ground, we rarely notice their presence. Sometimes only thin bands of cloud drift swiftly, almost unchanged in shape. Yet storms below often follow the paths traced by those high winds. They are quiet guides, deciding where rain will arrive and where the sky will open again to sunlight. Because of this, a rainfall in one city may begin with warmth gathered above an ocean thousands of kilometers away. A cold wind may carry the memory of distant polar ice. Weather is rarely the story of a single place. It is the motion of the entire planet. And when we realize this, the gentle breeze beyond the window seems to grow a little larger. It is not merely air passing by. It is part of a vast circulation connecting rainforest, desert, ocean, and ice within the same breath. In the quiet of night, when sound settles and fades, we may imagine the atmosphere as an invisible ocean flowing around Earth. Unhurried, unceasing, a machine without gears, moving through light, rotation, and the patience of time. And somewhere within that flow, the wind continues to pass, carrying the stories of places we may never set foot upon, yet remain connected to, through nothing more than a very gentle breath. Water, the amplifier of energy. And as those vast currents of air continue their nearly endless journey around the planet, a quiet companion always travels with them. Unloud, not easily noticed, yet capable of changing everything it touches. That companion is water. Perhaps we are accustomed to thinking of water as something familiar and close. A glass resting beside the bed, rain falling upon a metal roof in the evening, a river moving quietly through a city after the lights have dimmed. Yet most of Earth's water does not exist in forms easily seen. It lives within the air itself, invisible, so light that we walk through it without realizing we are moving among very thin oceans. Sunlight touched the surface of the sea many hours earlier. There, individual water molecules receive energy and begin to separate from their neighbors. Without boiling or making any sound, they leave the ocean in silence, rising into the air like small travelers. The ocean does not lose its shape all at once. Little by little, vapor is simply offered upward to the sky. When water leaves the sea, it carries energy with it, a kind of energy that cannot be seen through temperature alone. The surface where evaporation occurs becomes slightly cooler, like skin after sweat dries in the wind. That energy remains hidden within the vapor, traveling thousands of kilometers unnoticed. Air carries those water molecules as it moves, across oceans, through forests, over unfamiliar lands. Some days the air is so dry that lips crack in cold wind. On other days it feels heavy with moisture, as though everything around us is breathing more slowly. Air does not hold water equally at every temperature. Warm air resembles a wider bag, capable of carrying more vapor while still appearing clear. As it cools, that bag slowly shrinks. Water molecules no longer have enough space to remain invisible. That moment is familiar to anyone who has seen dew forming on grass in the early morning. During the night, the air cools. Vapor can no longer remain as before. It gathers into small droplets, shining beneath the first light of day. In the sky, the same process unfolds on a far greater scale. As warm air rises within the planet's broad circulations, it carries moisture gathered from oceans and land. Higher above, pressure decreases. The air expands and cools. That cooling encourages water vapor to seek something to cling to, not randomly within empty space, but around tiny floating particles drifting unseen. Dust from distant deserts, sea salt lifted by wind, or grains of pollen that have traveled hundreds of kilometers. Water molecules attach themselves to those particles, gathering into droplets so small they can scarcely be imagined. Billions of such droplets appear together, and a cloud is born. From the ground, clouds seem solid, yet inside them there is mostly air. The droplets are so small that they can remain suspended within rising and sinking currents for a very long time before ever falling. Some clouds swell upward like soft mountains, bright white beneath midday sunlight. They often appear on days when the ground has been strongly warmed, when air rises in gentle columns. Others spread into thin gray layers, covering the sky like a wide blanket, softening the light and making sound seem more distant. And far above, near the cold edges of the familiar atmosphere, the delicate feather-like strands drift slowly, reflecting sunset into pale golden traces. They differ in shape, yet tell the same story. Air has risen. Water has changed its state. When vapor returns to liquid droplets or ice crystals, the energy once hidden within it is released back into the surrounding air. That release is quiet but powerful. The air receives additional warmth, becomes lighter once again, and continues rising higher. From that moment, an amplification begins. Energy absorbed over the ocean returns to the sky somewhere else. A storm may be nourished by sunlight that touched the sea many days before. Rain falling upon mountains may carry vapor that once rose from forests far away. If this planet were dry, like certain other worlds in the solar system, the sky might be far quieter. Wind would still exist. Light would still warm the surface. Yet without water, the exchange of energy would weaken, like music missing the steady rhythm beneath it. Water deepens everything. It allows heat to travel far without being lost. It allows small motions to grow into towering columns of cloud reaching upward. It turns warmth into rain, and rain returns again to rivers and then to the ocean. This cycle has no clear beginning. A single droplet may have risen into the sky dozens of times before touching a window on some evening. It may once have been ice near a distant pole, then dew upon a leaf, then vapor within a seasonal wind. Even the humidity we feel upon our skin is part of that long story. When air carries much vapor, sweat evaporates more slowly, and warmth lingers upon us. When the air is dry, moisture leaves the skin quickly, bringing a gentle coolness. Air and water therefore remain in constant conversation. One carries motion, the other carries hidden energy. On quiet afternoons, when we look upward and see clouds drifting slowly through fading light, it is easy to think they wander without purpose. Yet within them are long journeys of oceans, of sunlight, of temperature changes unfolding little by little. And somewhere above, countless droplets are still forming, dissolving and forming again, like thoughts arriving and departing as the mind slowly drifts towards sleep. The sky continues to breathe. Water continues to travel. And between those two movements, weather becomes more alive, deeper, as though the planet is telling its story through clouds moving very slowly across a windless afternoon. Storms, fronts, cyclones, and extreme weather. And then, as water continues its passage through the sky in cycles without clear beginning or end, there are moments when that movement deepens slightly. Air is not always gentle. At times it carries more energy than can remain quietly held within familiar balance. Like a lake that appears perfectly still, while beneath the surface different currents gather, waiting only for a small disturbance to begin spreading outward. There are days when the sky is so clear that nothing seems capable of changing. Warm air rests near the ground, soft and light. Higher above, colder air exists quietly, like another layer of water within the same ocean. When that difference becomes large enough, only a small trigger is needed. Warmth rising from a road, a distant breeze, or air lifted along a mountain slope to awaken upward motion. A mass of warm air begins to rise more quickly than usual. At first, gently. Yet, if it remains warmer than the surrounding air as it ascends, it continues lifting itself, carried upward by its own lightness. The energy hidden within that temperature difference is like an unspoken promise. It is not yet a storm, only the possibility of a greater movement. The first clouds appear, white and soft as they often are. But sometimes they do not stop there. Water vapor condenses, returning heat to the rising air. That warmth makes it lighter still, and the ascent continues. The cloud grows taller, reaching colder regions of the sky, where it spreads outward like an opening canopy. From the ground, it may seem only a cloud growing larger through the afternoon. Yet inside, rising and sinking currents meet one another. Droplets grow heavier. As they fall, they pull colder air downward with them, and a new wind appears at the surface. A thunderstorm begins to breathe in its own rhythm, drawing inward, pushing outward, until its energy slowly fades. In some places above warm oceans, the story lasts longer. Air carrying moisture turns slowly around a region of low pressure. The turning planet bends its path. Instead of rushing directly toward the center, the air begins to spiral. As water condenses within towering clouds, heat is released back into the sky, lowering pressure further. Winds strengthen. More air is drawn inward. Seen from above, bands of cloud curl into a graceful spiral, almost peaceful if one does not know what unfolds beneath. A quiet clearing may appear at the center, where the sky brightens and winds soften. Around it, winds accelerate, carrying rain and lifting the sea into waves. Storms like these do not last forever. When they move away from warm water or reach land, their source of energy gradually weakens. They fade and disperse, like a long breath finally released. Farther toward temperate regions, warm and cold air often meet along boundaries stretching thousands of kilometers. They do not immediately mix. Instead, they slide across one another. Heavier cold air presses beneath. Lighter warm air lifts above. Long bands of cloud appear before rain arrives. Pressure falls slowly. Winds change direction. A gentle day may turn into cold rain without any clear warning. Large rotating systems form from these encounters, bringing snow to one place and rain to another within the same broad movement. High above, fast winds continue to guide events below. They curve into immense waves around the planet. When those waves deepen more than usual, cold air from the north may drift far southward, bringing unexpected cold days. Elsewhere, another curve may hold warm air in place too long, preventing the ground from cooling after sunset. Prolonged heat often begins with stillness. Air sinks from above, compressing and warming as it descends. Clouds struggle to form. Sunlight reaches the surface directly. Heat accumulates day after day, like a room with closed windows during summer. At times, Moisture from the oceans gathers into long streams within the lower atmosphere. Invisible from the ground, satellites reveal them as ribbons of vapor stretching thousands of kilometers, like rivers flowing through the sky. When they meet mountains or colder air, water falls continuously, bringing snow to high peaks or heavy rain to valleys. Within strong storms, winds at different heights may move in different directions. When rising air encounters that sideways turning, motion begins to twist. A rotating column may form within the cloud, narrowing as it extends downward. It does not always reach the ground. Yet sometimes, when every condition aligns, a slender vortex appears between cloud and earth. From a distance, it can seem as though the sky itself is touching the planet. Such phenomena often lead people to think of violence or chaos. Yet from a wider perspective, they remain part of the same familiar story. Energy is searching for a path. Heat is moving from places of abundance toward places of need. The air is not angry. The ocean is not enraged. They are simply responding to the differences created by light. After a storm, the sky often becomes remarkably clear. The air feels cooler. Morning light seems slightly sharper. Leaves still wet with water tremble gently in a new breeze. Perhaps what surprises us most is not the strength of these events, but the way they still belong to the same system that once carried a quiet evening breeze. From a brief thunderstorm to a vast ocean cyclone, everything begins with small differences in heat and moisture. And when night returns, when distant rain fades or the wind settles beyond the window, the sky resumes its search for balance. Unhurried, unceasing, as though the entire planet is learning to release its breath very slowly, after carrying so much energy through itself. The ocean, forecasting, and chaos. And after storms have passed, after the wind slowly loosens its hold upon rooftops and open seas, the planet returns to a deeper, slower breath. Not every movement unfolds within hours or days. Some stories of weather extend far longer, quietly enough that people rarely realize they are living within them. Out there, where the ocean stretches toward the horizon, water does more than reflect light. It remembers light. Each day, the surface of the sea receives energy from the sun, without rushing to give it back. Water absorbs heat patiently, holding it within its dark depths. A wave may feel cool beneath bare feet in the morning, yet only a few meters below. Warmth from a previous season still remains, moving slowly like a memory not yet faded. Unlike land, which warms and cools quickly, the ocean is more patient. It gathers warmth across months, sometimes years. Ocean currents carry that heat across basins, slipping through straits and circling continents. In some places, water sinks because it has become colder and saltier, sliding deep into the sea. Elsewhere, warmer water rises from below, bringing with it energy preserved for a very long time. Seen from afar, the ocean may be imagined as a great heart-pumping warmth throughout the planet. Not quickly, not loudly, but steadily. In certain years, waters across the Pacific Ocean become slightly warmer than usual. No one standing along the shore notices immediately. Waves still arrive, as they always have. Fish continue moving through familiar coral reefs. Yet that small change in temperature is enough to weaken the winds that normally sweep across the ocean. When winds change, warm water spreads farther eastward. Clouds and rain follow. Lands once dry may receive more rainfall. Other places grow thirsty. A change that begins at the sea's surface may reach harvests on distant continents. Then, in other years, the ocean returns toward its former state. Winds strengthen again. Colder water rises near coasts. Rain returns to familiar places. These oscillations resemble the planet's slowly shifting position in sleep. So gradual they wake almost no one, yet enough to alter the dreams of many regions at once. This is why the weather of a single day differs from the climate of many years. A morning may feel unusually cold. A summer may seem gentler than memory expects. But climate is a far longer story, written by oceans, ice, and deep movements too slow for ordinary sight to follow. Human beings have learned to observe these processes through satellites, through floating buoys scattered across the sea, and through silent models running inside computers. Numbers appear, connecting themselves into maps of wind and heat. Then, one day in the middle of the last century, a scientist named Edward Lorenz was working with such numbers. He simply wished to save time. Instead of entering all the data again, he rounded a few small decimal values before running the model once more. The result became entirely different. A very small change at the beginning led the forecast along another path. Not because of a great mistake, only because tiny differences grew larger with time, like two roads that diverge slightly at first, yet drift farther apart the longer they continue. From that moment, people began to understand how sensitive the atmosphere could be. A small change in temperature or pressure may spread outward, influencing larger movements days later. The idea is sometimes described through the image of a butterfly gently moving its wings in one distant place, and weeks later, a storm forming somewhere else. Not because the butterfly created the storm, but because the system itself is sensitive to every disturbance. Like a still lake trembling after a single leaf falls upon it. This realization did not weaken science. Instead, it taught humility before the sky. Today, rather than relying upon a single forecast, meteorologists often allow many models to run together. Each begins from slightly different conditions, a small variation in temperature, a subtle difference in humidity. They resemble many parallel stories being told at once. When most of them agree, confidence grows. When they scatter in many directions, the sky is reminding us that the future has not yet been fully decided. Weather forecasting, therefore, is not a final certainty. It is more like listening to many quiet voices in the same room, than sensing which story is most likely to become real. And even as powerful computers perform millions of calculations each second, the ocean continues to keep its secrets. Deep currents may take centuries to complete a single cycle. Small changes upon the seafloor may not reveal themselves within a human lifetime. Perhaps that is what makes the sky feel both familiar and distant. We can understand much. We know why clouds form, why winds change direction, why rainy seasons arrive early or late. Yet gentle limits remain, places where the complexity of nature moves beyond the desire for complete prediction. On quiet evenings, when a weather report speaks of the possibility of rain tomorrow, we may remember that behind those words lies an entire ocean in motion. Slow currents moving through deep darkness, countless possibilities existing at once. Not an uncertainty to fear. Only a gentle reminder that this planet remains alive, changing from moment to moment. And within that uncertainty, the sky seems somehow closer. Not a machine entirely under control, but a story still being written. Through each breeze, each wave, each cloud, slowly passing through the long night. The integrated system and a philosophical closing. And so, while distant ocean waves continue carrying the memory of light, while forecasting models move quietly through the night inside rooms filled with the steady sound of cooling fans. The sky above us continues doing what it has always done long before any human being ever looked upward. It adjusts itself, not through sudden motion, but through gentle feedback loops, like breath returning to the body after every exhale. A small change rarely remains alone. It touches something else, and that in turn reaches back. When air warms even slightly, it can hold more water vapor. Vapor is invisible, yet it carries the ability to retain Earth's warmth. And so the initial warming deepens a little more, as though the atmosphere has wrapped itself in a thin scarf. No sound announces this. There is no clear boundary, only drifting water molecules quietly absorbing and releasing energy. Elsewhere, clouds appear. A low, thick, bright cloud may reflect sunlight back into space, softening the surface below. Yet high, delicate clouds, thin as winter breath, can hold warmth beneath them, like a light blanket laid across the night. The sky does not choose a single role. It cools and it warms, depending upon the fragile shapes of droplets smaller than dust. No one can stand beneath a cloud and know with certainty whether it is helping the planet cool or warm. Perhaps it is this dual nature that makes the atmosphere resemble a thinking being, even though it is only following very simple rules. Light continues to arrive. Heat continues searching for its way outward. Between those two flows, rare molecules play roles larger than their size. Carbon dioxide, methane, ozone. They occupy only a very small fraction of the air. Yet they listen to wavelengths that most other gases ignore. They absorb heat rising from the surface and send part of it back downward, not to hold warmth forever, only to slow its journey. Without that slowing, the surface of the planet would be so cold that liquid water would struggle to exist. Familiar oceans would become something distant and strange. The conversation between sea and sky might never have begun. Higher still, where air grows so thin that the feeling of weather nearly disappears, chemical reactions unfold quietly beneath ultraviolet light. Ozone forms and breaks apart, repeating millions of times each second. Fragile three-atom molecules absorb powerful solar energy, warming the air above. There, chemistry becomes an invisible shield. Dangerous light is held back before reaching the ground. No color, no sound. Only small collisions between atoms, yet enough to protect forests, oceans, and even peaceful sleep beneath rooftops. Everything is connected. Air moves because temperatures differ. Temperatures differ because light is absorbed unevenly. Light is absorbed unevenly because of atmospheric chemistry. And chemistry itself changes through the movement of wind and water. A circle without a clear beginning. If we watch long enough, we may realize that weather is not a collection of separate clouds, rains, or winds. It resembles a system telling its own story. Very simple rules repeating countless times, forming shapes no one designed in advance. A storm is not planned. A breeze holds no intention. Yet from billions of small interactions, large structures appear, spirals across oceans, curved cloud bands around the poles, jet streams bending across hemispheres. Order emerges from motion, like a snowflake forming from invisible vapor, or music appearing when individual notes arrive at the right moment. Sometimes this realization makes human beings feel small. Yet it may also offer something else, a gentle reassurance, because the atmosphere does not need control in order to function. It requires no reminder to seek balance. When one place becomes too warm, motion begins. When a region holds too much moisture, clouds form. When energy gathers, wind rises to carry it elsewhere. Not perfect, not hurried, only continuous adjustment. Feedback loops sometimes amplify change, sometimes soften it, like the human body conserving warmth when cold or releasing sweat when hot, without awareness, yet always responding. And when we look at the entire planet from far away, what appears is not chaos, but a system searching for balance. Energy arriving from the sun does not remain where it touches the ground. It moves from ocean to cloud, from equator to pole, from day into night. It changes form, location, and speed. Weather, at its deepest level, is simply that journey. A photon leaves the sun and takes 8 minutes to reach Earth. It warms a patch of water. The water evaporates. Vapor carries energy upward. Clouds form. Rain falls. Wind blows. Part of that heat returns again to space. A circle completed. Perhaps that is why, at the end of the day, when the wind softens and the sky grows quiet, a familiar feeling returns. Not because motion has stopped, but because it continues exactly as it always has. Air still drifts above rooftops. Jet streams continue bending far overhead. The ocean still holds warmth from the previous season. Molecules continue colliding in darkness. And within all these movements, the planet maintains a fragile balance, enough for life to continue. If we step outside on a windless evening, we may hear nothing unusual, only open space and the distant light of stars. Yet there, energy is still moving, slowly, patiently, never truly resting, like the breath of a world asleep and always awake.